What is transitive? If A comma B belongs to R and B comma C belongs to R, implies A comma C also belongs to R. If the line L1 is perpendicular to L2 and L2 is perpendicular to L3, verify whether L1 is perpendicular to L3 or not. If you take 5, if x is equal to 5, then 3x, 3 into 5, that's equal to 15, does not belong to the given set. So 15 does not belong to the given set. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in my previous class, we have discussed regarding a relation and the types of relation and equivalence relation. In this session, I am going to take the example for equivalence relation. Now, first, before going to the exact problem, let us recall what is equivalence relation. A relation R on a set A is said to be equivalence relation if it is reflexive, symmetric and transitive. Now, let us take an example first. Let T be the set of all triangles in a plane. Set of all triangles in a plane with R a relation in T is given by, what is the relation on the triangle given? T1 comma T2 such that T1 is congruent to T2. First triangle is congruent to second triangle. T1 is congruent to T2. Show that R is an equivalence relation. What is to prove here? R is an equivalence relation. As I told, what is an equivalence relation? A relation R on a set A is called equivalence relation if it is reflexive. What is reflexive? For all A comma A belongs to R. For all A comma A, for all A belongs to the set A comma A belongs to R, B comma B belongs to R, reflexive. The second one is the symmetric relation. Symmetric means what? If for all A comma B belongs to, if for all A comma B belongs to A comma B belongs to R, implies B comma A also belongs to R. If A comma B belongs to R, implies B comma A also belongs to R. And third one, reflexive, symmetric, and the third property is transitive. Transitive, for all A comma B comma C belongs to the set A, if A comma B belongs to R and B comma C belongs to R, implies A comma C also belongs to R. If these three conditions, if these three properties are satisfied, then such a relation R, then the R is called an equivalence relation on A. R is called an equivalence relation. Now, what is the problem given here? Now, just come, this is the definition for equivalence relation. So, this is what we are going to verify now. This is the definition for equivalence relation. Now, what is to verify here? On the set of triangles, congruent to is an equivalence relation. So, verify on the set of triangles, whether they are reflexive, symmetric and transitive. Now, let us come to the first one. Now, let me explain reflexive relation. What is reflexive? R is reflexive since every triangle is congruent to itself. T1 is congruent to T2. Every triangle is congruent to itself. So, if this is a triangle, this triangle is congruent to itself. T1 is congruent to T1. That means T1 is congruent to T2. Therefore, R is reflexive. So, every triangle is congruent to itself. T1 is congruent to T1. Therefore, T1 comma T1 belongs to R. T1 comma T1 belongs to R means T1 is congruent to T1. Therefore, R is reflexive. Because this property A comma A belongs to R is satisfied, T1 comma T2 belongs to R implies T1 is congruent to T1. Therefore, it is reflexive. Now, second one, symmetric property. R is symmetric since T1 comma T2 belongs to R implies T2 comma T1 also belongs to R. If one triangle T1 is congruent to T2, if a triangle, this is a triangle, this triangle T1 is congruent to triangle T2 means T2 is also congruent to T1. So, T1 is congruent to T2 and T2 is also congruent to T1. That means A comma B belongs to R implies B comma A also belongs to R. Followed. So, therefore, T1 is congruent to T2 implies T2 is also congruent to T1. That is T1 comma T2 belongs to R implies T2 comma T1 belongs to R. Therefore, R is a symmetric. That is, this property is satisfied. A comma B belongs to R implies B comma A also belongs to R. T1 comma T2 belongs to R implies T2 comma T1 also belongs to R. That is, if T1 is congruent to T2, then T2 is also congruent to T1. Therefore, it is symmetric. Reflexive, then symmetric. The third property is the transitive. Transitive. What is transitive? If A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R. Whereas this is transitive because if R is transitive, since T1, triangle 1 is congruent to T2, then T2 is congruent to T3 implies T1 is also congruent to T3. So here, see here, this is triangle 1. Triangle 1 is congruent to T2 and this T1 is congruent to T2, T2 is congruent to T3 implies T1 is also congruent to T3. So that is T1, yes, T1 is congruent to T2 and T2 is congruent to T3 implies T1 is also congruent to T3. Therefore, R is transitive. So, it is reflexive, symmetric and transitive. Therefore, R is an equivalence relation. That's it. Very simple problem for 5 marks. You may expect this for 5 marks, even for 7 marks also. So, every triangle is congruent to itself. T1 comma T2 belongs to R. Reflexive. Symmetric. If T1 is congruent to T2, then T2 is also congruent to T1. That means, if a triangle T1 is congruent to T2 means the triangle T2 is also congruent to T1. So, therefore, this is symmetric. And the third property, reflexive, symmetric, and the third one is the transitive. If one triangle T1 is congruent to second triangle T2 and T2 is also congruent to T3 means then T1 is congruent to T3. So, that is T1 is congruent to T2, T2 is congruent to T3 implies T1 is also congruent to T3. Therefore, R is transitive. Hence, R is reflexive, symmetric, transitive. Therefore, R is an equivalence relation. So, that means on the set of triangles which are congruent to, on the set of triangles the relation defined by is congruent to is an equivalence relation. Now, let us take an example number 2. Let us take an example 2. Now, what is an example 2? Let L be the set of all lines in a plane, set of all lines in a plane, and R be the relation in L defined by R is equal to L1 comma L2 such that L1 is perpendicular to L2. Show that R is symmetric. This is symmetric but neither reflexive nor transitive. Now, what is to prove here is R is symmetric. Symmetric means A comma B belongs to R implies B comma A belongs to R. This is to be proved. R is symmetric by neither reflexive. That is A comma A does not belongs to R. A comma A does not belongs to R. That is not reflexive. And but neither reflexive nor transitive. Transitive, what is transitive? A comma B belongs to R and B comma C belongs to R implies A comma C belongs to R. So, verify whether these two properties are satisfied or neither reflexive nor transitive, but it is a symmetric. Now, let us know. Let us verify this. Now, reflexive. R is not reflexive since L1 cannot be perpendicular to itself. A line L1 cannot be perpendicular to L1 itself. So, L1 comma L2 does not belong to R. So, the line L1, this line cannot be perpendicular to itself. L1 cannot be perpendicular to L1. Therefore, A comma A does not belong to R. That means L1 comma L2 does not belong to R. Therefore, this is not reflexive. So, any line L1 is not perpendicular to the same line. So, L1 is not perpendicular. L1 cannot be perpendicular to itself, right? L1, this line cannot be perpendicular to the same line. So, therefore, this is not a reflexive. L1 comma L1 does not belong to R. Now, second property, symmetric. So, R is symmetric as the line L1 is perpendicular to L2, then L2 is also perpendicular to L1. See here, this is L1, here this is L2. If L1 is perpendicular to L2, definitely this L2 is also perpendicular to L1. See here, the line L1 is perpendicular to L2. Then if you consider this line L2 is perpendicular to L1. This line L2 is perpendicular to L1. Right. So that means if L1 is perpendicular to L2, L2 is also perpendicular to L1. What is this property? If A comma B belongs to R implies B comma A belongs to R means then it is a symmetric. So therefore the given relation is symmetric. That is R is symmetric as the line L1 perpendicular to L2, which implies L2 is also perpendicular to L1. L1 comma L2 belongs to R implies L2 comma L1 also belongs to R. L1 is perpendicular to L2 implies L2 is perpendicular to L1. Therefore, L1 comma L2 belongs to R implies L2 comma L1 belongs to R. Therefore, R is a symmetric. R is symmetric. This is not a reflexive. Next, this is not reflexive. Next, let us verify whether it is transitive or not. What is a transitive property? If A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R. In terms of the perpendicularity, if the line L1 is perpendicular to L2 and L2 is perpendicular to L3, verify whether L1 is perpendicular to L3 or not. See here, R is not a transitive because the line L1 is perpendicular to L2 and L2 is perpendicular to L3, then L1 cannot be perpendicular to L3, right? See, if L1 is perpendicular to, if this is the line, if L1 is perpendicular to L2 and this L2, if this L2 is perpendicular to another line L3, if L1 is perpendicular to L2 and L2 is perpendicular to L3, then N1 cannot be perpendicular to the line L3. So, right. So, here, so R is not transitive as L1 is perpendicular to L2 and this L2 line, this line L2 is perpendicular to L3, then L1 cannot be perpendicular to the line L1. So, L1 cannot be perpendicular to L3. That means R is not transitive because L1 is perpendicular to L2 and L2 is perpendicular to L3 implies L1 cannot be perpendicular to L3. That is L1 comma L2 belongs to R and L2 comma L3 belongs to R, implies L1 comma L3 does not belongs to R. Therefore, this is not a transitive. So, only symmetric, neither reflexive nor a transitive. Hence, this is not an equivalence relation, but the given relation is, the relation is symmetric, neither reflexive nor transitive. Followed. Now, let us come to the next example. Example number 3. Show that on the relation R in the set 1, 2, 3, given by R is equal to 1, 1, 2, 2, 3, 3, 1, 2, 2, 3 is reflexive but neither symmetric nor a transitive. This is reflexive, neither symmetric nor a transitive. Now, what is given here? Now, what is to verify? Show that on the relation, on the set, what is the set given? A is equal to 1, 2, 3. Then what is the relation given? R is equal to, the relation is 1, 1, then 2, 2, then 3, 3, then 1, 2 and 2, 3. Now, what is to verify? So, just to verify that is reflexive but neither symmetric nor a transitive. What is reflexive relation? Reflexive is A comma A belongs to R. Then what is symmetric? Reflexive? Symmetric. A comma B belongs to R implies B comma A belongs to R. What is transitive? Transitive properties, A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R. So, clearly you can say A comma A, 1 comma 1 belongs to R, 2 comma 2 belongs to R, 3 comma 3 belongs to R. So, therefore, R is reflexive, right? We can say that R is reflexive. Here R is reflexive. Now, verify the next property, symmetric. What is symmetric property? Symmetric. What is symmetric? A comma B belongs to R. A comma B belongs to R implies B comma A belongs to R. Verify. Let us take 1 comma 2. 1 comma 2 belongs to R implies 2 comma 1 does not belongs to R. So, we have 1 comma 2 here. 1 comma 2, but 2 comma 3 is not, 2 comma 1 is not there. Similarly, 2 comma 3 belongs to R implies 3 comma 2 does not belongs to R. This 3 comma 2 is also not there in the given relation. Therefore, R is not a symmetric. This is not symmetric. R is not a symmetric. So, R is reflexive, not a symmetric. Now, verify the transitive property. Transitive. What is R? We have R is equal to 1 comma 1, 2 comma 2, 3 comma 3, then 1 comma 2, 2 comma 3. Now, verify the third property. Third one is the transitive. What is transitive property? Transitive relation. If A comma B belongs to R and B comma C belongs to R, implies A comma C also belongs to R. Now, let us take 1 comma 2 belongs to R. 1 comma 2 belongs to R and 2 comma 3 belongs to R, right, implies 1 comma 3 belongs to R. Check whether 1 comma 3 is in the set, 1 comma 3 does not belongs to R. So, A comma B belongs to R and B comma C belongs to R implies A comma C does not belongs to R. 1 comma 3 does not belongs to R. Therefore, R is not a transitive. Therefore, R is not transitive on A. R is not transitive relation. See, 1 comma 2 belongs to R and 2 comma 3 belongs to R implies 1 comma 3 does not belongs to R. 1 comma 3 is not in the given relation in the set. So, therefore, R is not a transitive. This is just only a reflexive, but neither this is nor a symmetric nor a transitive. Now, hope you got an idea. Now, let us come to the next problem. Determine whether the relation R in the set A is equal to 1, 2, 3 up to 14 defined by R is equal to x comma y such that 3x minus y is equal to 0 is reflexive, symmetric and transitive. Determine, that means we have to verify whether it is reflexive, symmetric and transitive. Now, let us write down the relation. The relation is given R is equal to, what is the relation? R is equal to x comma y such that 3x minus y is equal to 0. What is the meaning of 3x minus y? Here 3x minus y is equal to 0 means 3x is equal to y. See, if the first element is x, then the second element is 3 times x. That's it, x comma 3x. Here the relation is x comma 3x. Write down the elements. If x is equal to 1, y is equal to 3 into 1 is 3. See, if you substitute here, 3 into 1 is 3 minus y is 3, 3 minus 3 is 0. Second, if x is equal to 2, second number is 3 into 2 is 6. Again 3, 3 3s are 9. Again 4, 4 3s are 12. If you take 5, if x is equal to 5, then 3x, 3 into 5, that's equal to 15 does not belongs to the given set. So, 15 does not belongs to the given set. So, we cannot take only the elements of the relation R. R contains 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. Okay, see. Here, if you substitute these values, x is equal to 3 and y is equal to 4, 3 4s are 12 minus 12, that is 3x minus y is equal to 0. 3 into x is 4, y is 12, 12 minus 12 is equal to 0, right. This property is satisfied. So, therefore, the values of x and y are nothing but x comma 3x, multiples of 3x up to 14, right. 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 9. Now, verify whether it will satisfy all the 3 properties. Now, let me verify one by one. What is R? R is equal to 1 comma 3, then 2 comma 6, then 3 comma 9, then 4 comma 12. Now, verify one by one. Now, first one is reflexive. Reflexive. Check whether A comma A belongs to R is there or not. A comma A belongs to R. 1 comma 1, 2 comma 2 does not belongs to R. A comma A, 1 comma 1, 2 comma 2, 3 comma 3 does not belongs to R. So, therefore, R is not reflexive. R is not a reflexive. Second one, symmetric. Symmetric. What is symmetric? A comma B belongs to R implies B comma A belongs to R. Now, let us take any element. 1 comma 3. 1 comma 3 belongs to R implies 3 comma 1 does not belongs to R. So A comma B belongs to R implies B comma A does not belongs to R. So 2 comma 6 belongs to R, 6 comma 2 does not belongs to R, 3 comma 9 is there, 9 comma 3 is not there, 4 comma 12 belongs to R, but 12 comma 4 does not belongs to R. So therefore R is not symmetric. R is not a symmetric. And the last property, transitive property. Transitive. What is transitive? If A comma B belongs to R and B comma C, if A comma B belongs to R and B comma C belongs to R, implies A comma C belongs to R. Let us take these elements. 1 comma 3, 1 comma 3 belongs to R, 1 comma 3, and 3 comma 9, 3 comma 9 belongs to R, implies 1 comma 9 does not belongs to R. 1 comma 9 is not in the relation R. So that means R is not transitive. Therefore R is not transitive. R is not transitive. So the given relation R is neither reflexive nor transitive nor symmetric. It is neither reflexive nor symmetric nor transitive. Hence this is not an equivalence relation. This is not an equivalence. So A comma B belongs to R and B comma C belongs to R implies A comma C does not belongs to R. Therefore this is not transitive. So the given relation is not reflexive, not symmetric, not transitive. That's it. Very important type problem for a 5 marks. Now let us take one more example. Next problem, determine whether the relation R in the set n of natural numbers defined by R is equal to x comma y such that y is equal to x plus 5 and x is less than 4 is reflexive, symmetric and transitive. Now what is the condition given? R is equal to x comma y such that y is equal to x plus 5 and x is less than 4. So we can take x is equal to 1, 2 and 3. X is equal to 1, 2 and 3. Then what are the values of y? When x is equal to 1, y is equal to 1 plus 5 is equal to 6. When x is equal to 2, y is equal to 2 plus 5, that's equal to 7. When x is equal to 3, y is equal to 3 plus 5 is equal to 8. So what are the elements of the relation? So therefore R is equal to 1 comma 6, then 2 comma 7, then 3 comma 8. These are the elements of R. See, x comma y such that y is equal to x plus 5, where x is less than 4. X is less than 4 means 1, 2 and 3. If you add 5 for this, 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8. Now verify whether it is reflexive, symmetric and transitive one by one. Reflexive. So here 1 comma 1, 2 comma 2 does not belongs to R. A comma A does not belongs to R. Therefore R is not reflexive. R is not reflexive. R is not reflexive. Now the second one, symmetric. Symmetric. Verify whether A comma B belongs to R implies A comma B belongs to R implies B comma A also belongs to R. Now let us take any element 1 comma 6. 1 comma 6 belongs to R implies 6 comma 1 does not belongs to R. 2 comma 7 belongs to R. 7 comma 2 does not belongs to R. 3 comma 8 belongs to R, but 8 comma 3 does not belongs to R, right? Okay. Now therefore what do you say? This is not symmetric. R is not symmetric. R is not symmetric. R is not reflexive, not symmetric. And verify the last property, transitive property. Transitive. What is transitive? If A comma B belongs to R and B comma C belongs to R implies A comma C belongs to R. Let us take any element. Here this condition is not satisfied at all. So A comma B belongs to R and B comma C belongs to R implies A comma C does not belongs to R, right? So therefore R is not transitive. So therefore the given relation is neither reflexive nor transitive nor symmetric. Hence this is also an example for not an equivalence relation. This is not an equivalence relation. That's it. So here the elements of the relations are of the form x comma x plus 5, that is x comma x plus 5, 1 comma 6, 2 comma 7 and 3 comma 8. That's all. So these are few example for a equivalence relation and not an equivalence relation. So that is the three important properties: reflexive, symmetric and transitive. That's all regarding today's sessions. Hope you got an idea how to verify equivalence relation. So that's all. Let us meet with the different concept in the next session. Thank you. Thank you very much.